Okay, so welcome to my Master of the Skies Weather Briefing Weather Show, where we talk about all things weather as it relates to weather forecasting, and where we discuss weather processes that I talk about in my ebook and in my training course. And so here we're going to be taking a look at the 300 hectopascal or millibar height level chart, and here we're centered on the European continent using the GFS weather forecasting model over Europe, using the Pivotal Weather site that has a lot of interesting weather graphics and weather charts. So here we could see, if we take a look closely, that we're dealing here with an upper level ridge. You could see the height pattern that basically carves out a ridge over Central Europe. And then we have a large, pretty deep trough extending over most of Scandinavia and Eastern Europe into Romania, Bulgaria, and parts of Ukraine. And another trough out here in the Eastern Atlantic with a rather strong jet stream coming in from the southwest. So that's the upper level pattern as it stands there. And you could also see basically the wind barbs representing the wind speed at this pressure level, where you could see 30 knots here. And then as you get closer to the jet core, you get really strong winds up to over 120 knots here in the core. So you can see that the winds will also vary depending on where the jet stream is located and around the upper level flow in general. So now we're going to take a look at some other graphics just to show you here some of the same representation. So we were centered on Thursday around 8 p.m. Local time over Western Europe on this Thursday, August 10th. And you could see that we find again this ridge over Central Europe as we saw on the last chart. And you could also see that jet stream associated with that deep trough of low pressure over the eastern North Atlantic. And then this other trough here located over Eastern Europe, extending from Scandinavia down over into Eastern Europe. So you could see here where you actually have the streamlines that are basically animated. You could see it helps better visualize the upper level flow and how the air is actually flowing through this pattern. You could see that it's pretty quick through the jet streak here over the Eastern Atlantic, and then the flow sort of slows down over the ridge and then speeds up again into the fast flow associated with the trough of low pressure. Now, what's interesting is that if you remember when we talked about in the ebook and the training course that usually ridges of high pressure are associated with clear skies and clement weather, and troughs are usually associated with cool, damp, and perturbed weather. And we're going to take a look at how actually the pattern looks via satellite imagery, and whether if or not we can pick out, for example, some frontal features at the surface and which zones are actually free of clouds. And so forth. So you would basically expect to have rather clear skies under this ridge to some extent, and then more perturbed weather associated with this low pressure system you can see here, and also associated with the trough of low pressure. So let's take a look at that. And here, this is the satellite imagery that corresponds to that time. And basically, you could see, if I zoom out a little bit, maybe you could see it a little bit better. You could see this clear skies associated with that ridge. You could also pick out clearly this low pressure system spinning out here in the Eastern Atlantic here. You could also pick out the clouds associated with that deep trough over Eastern Europe with all these clouds spinning around both of these low pressure systems. And if you remember, I can zoom in a little bit again, we could actually pick out some of the fronts. Now, if you can remember, when we talked about frontal systems, we could actually pick out some of these features. Now I can help highlight, for example, the warm front that you could pick out right here. And then I could also pick out the cold front that you could basically draw just like that. And even though I don't have the purple color, I could use the black color to show you the occlusion that's actually wrapping around the low pressure system, since the center of the low basically could be drawn like right there. So that really helps pick out the frontal systems when you look at it on satellite imagery, and the different sectors of the low pressure system. Here's the warm sector, the head of the system here, the cold sector behind the cold front, and then the occluded part of the cyclone. You could also pick out the deep trough here. If I were to draw the upper level trough as it was carving out right here, and you have some secondary low pressure systems within this trough, as you saw on the previous 300 millibar map. And if I also, I can actually, whoops, no, I can't. But anyway, you get the idea. And what we could also do is superimpose, what I can do is also superimpose the temperatures on this satellite imagery. And you could really see the warm sector where you have all this warm air here. These are temperatures in degrees Celsius. You could see we have 31, 32 degrees Celsius, which is about 88 to 90 degrees Fahrenheit. So really warm air here in this warm sector. And then just north of the warm front, you're really basically in the colder air, relatively colder air since we're in the summertime, but you could see 24 degrees Celsius, 19 degrees Celsius, 18 degrees Celsius, so much cooler air as you would expect ahead of the warm front and much warmer behind it in the warm sector. Then you have the cold front, and then you could see the sort of cooler air located out in the Atlantic in the cold sector. Same thing ahead of the occlusion here. Now you have some 20 degrees, 18 degrees, 20 degrees Celsius, and then behind it you're more like 14. So you can see you have sort of colder air here flowing, and you could also see some of the stratocumulus and cumulus clouds developing here over the Atlantic. You could also see some of the cumulus cellular convection going on associated with this cold upper level low here that's associated with this trough, and some of the cloud material advecting also ahead of it from the south, probably associated also with some thunderstorm activity, as you can see here ahead in the warmer air ahead of the frontal zone. So there you go. When you really merge together the temperature data, the cloud data, and also the upper level data, it really helps you sort of visualize how everything is basically all linked together. Now, we could also take a look at the precipitation field by looking at the radar, and you could see the precipitation associated with both low pressure systems, the one over Romania and Bulgaria, as well as the one located over Poland and then basically over the Baltic states and the Baltic Sea. And you could also see some of the precipitation associated with that strong low pressure system over the North Atlantic. Now, of course, since we don't have radar data over the ocean, you're not actually seeing some of the precipitation that's occurring in this region, but you could see sort of the occluded part of the cyclone, and then the cold fronts draping out here. Here you have radar from sort of the Azores, and you can sort of see some of these precipitation echoes from that radar, but of course, we're basically blind in terms of radar over most of the Atlantic. You could also see some slight precipitation here associated with the warm front that's moving through northern France and western Switzerland. So there's a pretty nice look at the weather situation for this day. Now, if I go back to the initial pivotal weather map, what we could also take a look at here is basically look at the air mass temperature anomalies, which will also give you an idea of what the temperatures, how abnormal the temperatures are for that period. Now, if I it's taking a little bit of time to load, but you could basically see some of the warm air in the warm sector and the cooler air behind the cold front, as you would expect. And you could see the deep low pressure at 850 here drawn in. You could also see a lot of the cooler air than normal that's associated with that upper level trough that's basically concerning most of Eastern Europe here, including some of even Greece and Bulgaria and Romania, Hungary, Poland, and southern Scandinavia. Here with ahead of the warm front, really ahead of the cold front, really warm weather, ahead of the occlusion as well, and also in the warm sector, and then behind the cold front, cooler than normal temperatures over parts of the Atlantic. So there you go. That was the weather show for today, just to show you some of the links between upper level weather, surface weather, and the different temperature contrasts between the different sectors of these low pressure systems in the mid-latitudes, and how everything pans out. So until next time, take care, and I'll catch you later.